So today I'm going to be demoing how to set up a Galaxy software instance on the cloud. For this demo, we'll be using Jetstream, which is a National Science Foundation cloud provided for free to academic researchers. However, this would also work on another cloud system, such as Amazon. But since we have a Jetstream account, we are going to use that today. The first thing you're going to want to do is launch a new instance. So log into Jetstream and go to your dashboard and hit new instance. And we're going to search for Ubuntu 16.04. We are going to be using a Docker container, so it should work on a number of different operating systems, but in this case, we have tested it on Ubuntu. It works great. Additionally, there is this very nice Ubuntu image that already has Docker installed, which will save us a few steps. So I'm going to click on that, and now I'm going to press launch. Now the Jetstream software is, the Galaxy software is a bit larger than will fit on a tiny instance. So I'm going to click on this drop down and go actually up to medium, and that's going to give us 60 gigs of disk space, which means we can actually load some data into Galaxy and test it and see how it's working. Okay, so once you have selected all of your options, you can hit launch instance. Now this is going to take just a few minutes to launch. Be patient, and we'll come back when it's ready. All right, so our instance is now ready. You can tell on your Jetstream project page, because you'll see that it says active. I actually have 2 active instances, and I know that I want to use one for Galaxy. So I'm going to click on it and click this little pencil and just rename it Galaxy. That's just gonna help me keep track of my instances. Okay, so for us to log into this instance, we need to copy the IP address, just right down here. And now I'm gonna launch a terminal so that we can SSH in. Make that a little bigger. So I'm gonna use my Exceed username and go straight to that IP address. Now, when your SSH keys are set up correctly with your Exceed user account, this should just log you right in without a password. So this is a perfectly clean Ubuntu image. Well, it does have Docker. And so that's probably the first thing we want to check. Let's make sure Docker is here and running. So I'm going to become root, and then I'm going to do Docker PS. So this will show me that Docker it's running and there are no current containers. We want to add a Galaxy container. Now this container was created by my lab. There are other Galaxy Docker installs available. This is a really nice one because it has some tools and some workflows already installed that we know work really well with Tripal, and that we can use for a quick demonstration. So I'm going to do Docker run IT, so that's just giving us a shell to work with our container, --rm. We want to now set up some ports. So we need to map the server ports to the container so that we can use these ports. Eventually this will be so that Tripal and Galaxy can talk to each other, and also so that we can get to Galaxy through the web. So we're going to do port 80. We're also going to get port 8021. And 8022. We're going to do a couple more command flags. It might be easier for you to just copy and paste this command from the documentation. You can put whatever email address you want in here, but I'm just going to use example@gmail.com because we're not actually going to need to receive any of those emails. And then finally, we need to tell Docker where to find this Docker image. It was produced by Ming Chen, And so it's part of his public Docker images. So we'll put his username, and it's called Docker Galaxy or Tripal Galaxy Demo. All right, so hopefully I've typed everything correctly. And now it is going to take some time to install everything. So this is going to not only install Galaxy, but also give us a number of bioinformatic tools and workflows that we're interested in using. This takes a few minutes to get all set up. So we will just wait on that and come back when it's ready. Okay, so our Docker container has now finished deploying. And you can see we have a new command prompt that shows us that we are inside the container. The last thing that needs to be done to get Galaxy to start is to execute the command startup. This is also going to take just a minute to get everything started up and running. Okay, so our Galaxy instance has now started up. We're starting to see some log records on our shell screen. And so now we can go and see if we can see Galaxy through the web. I'm going to copy this IP address again, the same Jetstream IP address, and then open a new tab and paste it into the browser bar. We do have a functional Galaxy instance now. Just ready and waiting to run some bioinformatic workflows. So the first thing we need to do is to finish registering a user account. Now, when we set up the Galaxy using Docker, we specified example@gmail.com as the administrative account. So we're going to go finish setting that up. So we're going to go to user register and put in example@gmail.com. We can type some relatively simple password and give yourself a public name. Okay, so we are now logged in. And at this point, you could start uploading files and using tools. The Tripal, you'll notice there's a Tripal Galaxy demo down here. So these are just some of the tools that we have installed as part of the Galaxy container and that come already pre-installed in Galaxy. It includes BDSS, which is a method of transferring files more quickly from various data services, WGCNA, which is a gene co-expression network software, and a few other things. We can also get data, so I'm going to upload a few files. I have an expression file and a trait file. And these are going to be great for running WGCNA. Okay, so we have our two files. And now we can go import a workflow. So we go to the workflow tab. Currently there are no workflows, but we can add some. So we're actually going to go, you can create your own, or we can upload or import a workflow. And since there are already a number of workflows that we know work well with Galaxy and with Tripal, I'm just going to import one of those. You can find them on GitHub. And let me show you how to find that. So the Staten Lab GitHub repository has a number of workflows. And this is just one. This is what a raw Galaxy workflow looks like. So I'm going to paste that in here and select import. Great. And now I can run this workflow. And at this point, we would need a reference genome and also some reads. We can add another workflow. This time, because I uploaded data for WGCNA, I am going to go get a workflow that uses WGCNA. Paste it right there and import it. Perfect. And now we'll go and run this one. Okay, so it's tried to guess the correct files. And in this case, it has not recognized that the expression data is a CSV. It got, let's see, it is, should be a CSV. So I'm just going to change that. Perfect. So now I can go back to my workflows, run this, and now I can select my expression data for the expression data and the trait data for the trait data input. At this point, you may wish to click through and change any options, but I'm pretty happy with the default, so I'm just going to go ahead and run this. You should very quickly see it showing up in your history sidebar and start seeing yellow spinning wheels to indicate that it's running. The WGCNA workflow has finally completed. We can click through each step. Now normally WGCNA would stop at this step, and viewing the details, you wouldn't get much in the way of visualization. You can download the output. But one of the things that we have added to this workflow and to a number of Tripal workflows, it's very exciting, is this special visualization. This is the GR report style of creating a visualization. These reports can be seen inside of Galaxy and also inside of Tripal. So for this one, it's telling you the first thing it did was import that workspace. It's going to tell you a little bit about how the clusters of genes were created, give you some of the command line information, and start telling you a little bit about each cluster. So in this case, we know there are 18 gene modules or clusters, and the largest one has 609 genes and the smallest has 34 genes. We can look at a dendrogram, kind of giving us the idea of how these clusters are related. Scrolling down, we can also see a network heat map, kind of looking at the similarity of the gene modules, and an eigengene visualization with some dendrogram clustering. So again, this is just a nice way to visualize the results and explore them prior to downloading the raw output.